My name is John Mulligan. I've spoken at sambaXP previously. The last time I was able to attend live, I was working with Red Hat. Now I am directly working in IBM. Previous years, I've presented on topics such as Samba operator for Kubernetes, Samba containers, and Samba containerization, and things like that. I also want to give a huge thank you to Michael Adam, who I've co-presented with the past. He kicked off the work on the Samba operator and the containerization effort, and he's who got me involved. So given my past presentation history, and if you've somehow conveniently forgotten the topic of this talk, you might think I was going to speak about Kubernetes again. But no, we're not going to talk about Kubernetes today. Today is all about Ceph, and in particular, non-Kubernetes-based Ceph. This is Ceph with its own management stack. Now, my audience engagement handbook says now is a good time to pause and ask the audience a few questions. So I think we can probably use the Zoom, what's that called? Reactions and as a thumbs up or whatever. So how many people have previously used Ceph? I know at least a couple of you have, so all right. How many people have used Ceph with Samba? Nice. All right, and then finally, how many people have at least heard of Ceph ADM orchestration? All right, I have a few audience plants that I really expected to see reactions from, so thank you. Thanks, everybody. Anyway, my own personal history is typically involved the management of storage systems. So the focus of the rest of the talk is largely on management topics. If you came here hoping for a deep dive on file system integration and things like that, well, maybe you have to wait until next year. What I'm trying to do is integrate Samba with Ceph's management stack, make it feel like a native part of Ceph's workflow and tooling. However, we're not throwing everything away that I've previously presented on. In fact, we're able to reuse the container images provided by the Samba Container project as is. We're still using the same Samba CC glue layer. It's just been enhanced for more Ceph-specific options. We also have done a lot of work testing Samba against various cluster storage systems. I highly encourage you to attend the talk later today by Anoop and Sachin. And then finally, despite not being able to reuse any of the code from the Samba operator, by doing that exercise, we were able to learn all sorts of various things that we can conceptually apply to the work on Ceph. It saved a lot of time from having to design things from scratch. This talk is not a deep introduction to Ceph. For those who haven't heard of Ceph, it is an open source distributed storage system. I did list a few core principles. One is that Ceph consists of multiple different layered storage protocols. Typically, Rados is the underlying protocol. And for our purposes, the other protocol we care about most is CephFS, because that's what we're going to integrate directly with Samba and SMB. These protocols are supported by server processes that run in the cluster. The one that interests us most today is the Ceph Manager. The manager is a bit of a grab bag of functionality. These are implemented through plugins, essentially, and it gives the manager the ability to, well, manage all sorts of various aspects of the Ceph cluster. And so we'll be focusing a bunch of our work in that area. Earlier, I mentioned Ceph ADM. Ceph ADM is Ceph's custom container orchestration system. It's dedicated to Ceph's needs. It doesn't try to be super general, but it is sufficiently general that you can run container images that aren't just Ceph's core daemons. A Ceph ADM installation mostly just requires Podman or Docker, systemd, and Python. So it runs on a wide variety of distributions. Ceph ADM is split into two pieces. One is a module that lives inside the Ceph manager. It's continually running, making decisions about where certain containers should be running in the cluster. And then on each node in the cluster, there is a Ceph ADM, what is colloquially called the binary, but I don't really think it's a binary. It's just kind of got that name. And it receives instructions from the manager module. Having worked with Ceph ADM for a while now, there's a few takeaways that I've learned, which are there are far fewer constraints on what we can do compared to building in Kubernetes directly. However, that means there are also fewer things available already to reuse. So we can kind of build whatever we want, but we have to build it. This is particularly true around the networking aspects, and we'll touch more on that later. While this is a Samba conference, Samba can't seem to help constantly get compared to NFS, as many of us know. And in this regard, Ceph already has an NFS support. In particular, it has an NFS manager module. And because this is kind of existing prior art, we want to make anything that we build somewhat familiar to admins so they don't have to totally learn two new systems. Ceph's NFS module allows you to create and destroy virtual clusters. These clusters could consist of just one server instance, but might consist of more. It also allows you to create, update, and remove NFS exports. When the NFS module needs to have a new Ganesha instance running on a node, it will reach out through the orchestration APIs to deploy container images. And one other interesting feature of Ceph's NFS support is that it can integrate with a Ceph feature called ingress. In Ceph, ingress is typically a combination of keep alive D and HA proxy, and it provides the system a fair amount of scale out and a quasi-HA, but I don't personally consider it HA. We could talk about more later if we have time. All right, so now we're getting into the stuff that we're actually doing. In 2023, I spent a good deal of time working on some fundamental refactorings of Ceph ADM. We needed to prepare it for all the various changes that were coming that were unique to the way we want to deploy containers for Samba. By doing that, we're able to replicate a large number of the features that we needed, that we had in Kubernetes. In particular, what we wanted were init containers. These containers are ones that run and then run to completion, one after another, before the primary daemon container runs. There are also sidecar containers. These are containers that run alongside the primary service and provide that primary service with supplemental features. Now, normally containers are very isolated from each other, so we also needed to allow our containers to share resources when we wanted them to share them. And then finally, we had to hit upon a bunch of various small improvements and bug fixes along the way. Late last year and early this year, I was able to add Samba support to Ceph ADM. What we needed was Ceph ADM to be able to create init containers for configuration, as well as Active Directory domain joins when we're acting as a domain member. We have a sidecar which monitors the state of the Ceph cluster and fetches configuration when it changes and applies that to the Samba instance running in the containers. Again, for domain members, we need a sidecar for Winbind. Then we have various other helper. Finally, to tie it all together and allow the system to access this container support, we need to define something called a service spec. The SMB service spec will tell Ceph ADM what containers to launch. So we can tell it, we want you to deploy the set of containers for domain or not. And we also need to be able to tell the system what CephX users, also known as entities sometimes, will be needed so that the Samba process can access the Ceph cluster. Finally, we're going to need to configure the Samba instance in a far more detailed way, but we don't really want Ceph ADM, the container deployment system, to know all this. So we were able to add a series of made-up URIs that tell the containers where to get its configuration, but this is mostly a pass-through for Ceph ADM. So once we had container support for SMB, we can start building a user interface for it. This is done, as I mentioned earlier, with a thing called a manager module. Our new SMB manager module provides the command line interface and APIs that you can use to create, update, remove clusters, shares, and other supplemental information. Our command line comes in two forms. One form I'm calling the imperative form, where your commands say things like cluster create or share create, share remove. But inspired by previous work with Ceph ADM, the NFS Manager module's NFS export apply command, and Kubernetes, I also wanted to add a more declarative interface. This declarative interface is based on resources. We have resource types currently for clusters, shares, user and group configuration, and join authentication information. Finally, the module has to synthesize, take all this information, and run the operation. When it needs to, it will reach out to the orchestration APIs and deploy container instances, or it might simply say, this is simple, a share update, and I don't need to go through the orchestration layer. Here's where we're getting into the meat of the presentation, and I'll be jumping over to a demonstration of our current work. Now, this is a work in progress. The PR has been posted on the Ceph project. There is some documentation available that I highly recommend that if you're interested in the subject that you can review without even looking at the code. And then finally, I'll mention that we've raised this topic already in the Ceph mailing list. We've already had some great feedback from the community. In fact, I think some of those folks are already active in the chat here, sambaXP, which is really great. But on that note, I'll pause for a moment to switch my screen. And all right, cool. All right, so the first command up top is we're aliasing the Ceph command to the Ceph ADM shell command. This is because this node is a purely container-based install. It has no Ceph packages installed already. Next, I'm going to do a quick introduction to the cluster. This is a small 3-node virtual machine cluster that's running the core Ceph services. So not much going on here right now. And here's the host ls command. You'll see that it has the 3 nodes. So next, we're going to create a cephfs file system. It's very common to call your cephfs file system cephfs. It's just a convention, can be a little confusing at times. And then we're going to create a subvolume group and a pair of subvolumes. And this is what we'll be sharing out using our Samba and Samba containers. And for more information on subvolume and subvolume groups, I highly recommend just taking a quick look at the Ceph documentation, or we can talk a little bit more in the Q&A section if we've got the time. Next, we're going to enable the new SMB Manager module. It's not enabled by default. And we'll run a simple cluster ls command just to make sure the module is loaded. Okay, we don't have any clusters as expected. Moving on, we're going to define our first cluster. This will be an Active Directory enabled cluster. We need to give it a name, tell it that it's using Active Directory, and then we'll provide a few basic parameters so it knows what domain to join. This is a domain controller running on one of our ADDC container images on another VM. It's a throwaway domain, so I'm using administrator. Don't normally do that, but do as I say, not as I do. Finally, I want to point out before we continue that the containers support custom DNS servers. This is done so that in the case that your domain controller is not tied into your host's DNS already, much like this setup is, you can have the Samba containers use DNS servers that are different from your underlying Ceph hosts. So no need to mess with the DNS servers of the Ceph nodes themselves. All right, our command emitted some JSON. I'm not going to go into a lot of detail, but I did want to point out that the state was created, and it was created successfully. We can see that our new cluster exists in the configuration, and we'll start defining some shares. Every share belongs to a cluster, so we need to identify the cluster and then the shares ID. This is a cephfs cluster. We're using the cephfs file system, and it is going to use the root of the subvolume SMB vol1. Once again, the state is shown as created, and it was run successfully. We'll create a second share, and we'll do it slightly different this time. In this instance, we'll also provide a share name, and the share name will be reflected in the SMB and Samba configuration. It allows for characters that the share ID doesn't. Just gives you the opportunity to give it a friendlier name. All right, so now we have a couple of shares. We can list them. I typoed. There we go. And then we can ask Ceph Orchestration what is running. We can see that we have an SMB TC1 instance. We can even ask the orchestration for more information, like what its port is and what node it's running on. And now we can hop over to our Windows client. This client is already joined to the same domain I mentioned earlier, so it really should just be a matter of putting in the host name. Okay, it's already recognized our shares. We'll do a quick test on these. we go. Okay, thank you for coming to my talk. Okay, there's more to it than that. Hopping back over to the command line, I'm going to use the Ceph SMP show command to list all of the details that are stored in the Ceph configuration. The show command can also put the output in YAML, and we can narrow down what it lists. We can tell it a particular resource type, such as Ceph SMP cluster or Ceph SMP share. And you can further narrow down the output by specifying the type followed by a dot and then the ID. In the case of clusters, this is just the single ID name. For shares, you can do the dot cluster name, or you can do dot cluster name followed by dot share name. Moving on, we'll do a second cluster, but first we need to set up additional subvolumes to share out. Once we've created those subvolumes, we can start by opening a file, because this time we're going to do the declarative style. I'm going to copy and paste an existing YAML file. That way you don't need to watch me make 500 typos. But I will annotate each resource. So the first resource in the list is our cluster resource. We're not going to use Active Directory this time to show that when we're running multiple virtual clusters, they can have totally different configurations. Our second resource is a users groups resource. This is defining users and groups for a standalone instance. It is referred to by a name inside of the cluster resource. Our final two resources are shares. Our first share only has the share ID, so the share ID will become the share's name. This is just like the previous example. And like the previous example, our second share does have an explicit name. We can send this configuration to the Ceph cluster using the Ceph SMP apply command. And it will list every resource and what its state was, and then an overall success status. We can see that orchestration has already started deploying the second cluster. However, it's not quite done yet. Orchestration does work asynchronously, so we might have to wait a few moments. Okay, it's up and running now. We'll hop back over to our Windows system, start putting in the host name, and in this case, we should get prompted for a username and password. Okay, looking good. And really, after this point, it's a very similar workflow from the first instance. I think for the second share, we'll do a slightly different example, but this will prepare us for the next part of the demo. So we'll create a directory, but we'll also go into that directory and add a demo file. Okay, back to our command line. We're going to copy our YAML so that we can edit it. We'll remove some of the extraneous configs that we don't really need to show in this part of the demo. And we'll change a couple properties of our second share. We're going to change the name, and we're going to adjust the path to match the directory we just created through Windows. We'll save it, and then we will, once again, send it to the Ceph cluster through the apply command. In this case, you can see that the state of the original or the first share is present, which means the share already existed and its configuration matched what was in the YAML, so no changes were needed. The second item is updated, meaning it applied some changes. We can hop back over to our Windows client to make sure our changes took effect. I did actually cut out a small piece of the video for time. I did disconnect the node from the cluster, from the share with the netuse command. Connecting to our new share, it has the name changed, and the file is in the root of the share, showing that we did, in fact, make some changes. Once again, we can see that the cluster knows about the clusters. The show command knows about the various new shares. And there's all sorts of different combinations that you can feed the system to get it to list what you want it to list. Finally, what we're going to do is use the declarative interface to remove these items. Once again, we'll copy some YAML. We can remove the various parameters and replace them with the intent parameter. The intent parameter has the value of removed. We're telling the system we want this thing to go away. Okay, so all of our resources are set to intent removed. And then once again, we can use the apply command and get rid of these various items. Listing the clusters show that we only have TC1. And similarly, the results are reflected in the show command. We no longer have any shares in the TC2 cluster. And that is that for the recorded section of the demo. Do we have any quick questions before I move on to wrap up the talk?
I have a question, John.
Sure.
Several. So first of all, is it correct that the orchestration and management pieces that you showed are all merged in upstream Ceph?
No, these are mostly in a PR. Okay,
got it. Next thing is I'd be interested in knowing what Samba is configured, like SMB configuration, and does it use a CDDB, VFS module, stuff like that?
Okay, so CDDB will be mentioned on my next slide, so I'll get into more detail once I get to that. As for the back end, it is currently using the existing VFS module simply because it's easier to integrate in containers. I had started working on an alternative backend to use the file system mount, but I ran out of time before I did my demo, so I wasn't able to include that.
Okay, thanks a lot for the clarification here.
Sure. All right. So, as we just touched on, one of our big major to-do items is to integrate with proper clustering. As I keep saying in this talk, we have learned a lot from our operator efforts. And in fact, the operator does have some basic clustering CDDB support. However, unlike other features of the operator, it never really got mature, so it's behind a feature gate. But that doesn't mean we can't learn anything from that effort. So while it seems like a big major development task, I do think it will, we're not starting from scratch. So I anticipate a lot of work, but I think it'll be doable. In addition to that, we're going to be doing some metrics and monitoring exporting. There's already a convention within Ceph to use Prometheus metrics. Prometheus metrics are integrated with Ceph's dashboard, its management UI. So we should be working soon on a sidecar container to help us do this metrics export. Next, what I've demoed here today has a fairly strict and simple configuration. As I've mentioned, we already have some engagement with Ceph community. We got a lot of good feedback around things like ID mapping options and some other things. While we're not going to expose all of the configuration that Samba allows, we do know that we're going to need to give administrators some level of configurability. It's going to be a balancing act. But in the case of someone who truly needs to hack on something, I don't want to force them to edit the code. So we'll most likely add an special option to allow you to specify your own SMB conf parameters as a key value thing. But if you do this, we'll most likely do something like a health warning or something along those lines that say, you've kind of gone off the rails to do your own thing. If you break it, you get to keep both pieces, but you'll still have that option. In the further term future, we have a lot of research to do around networking. As I mentioned earlier, Ceph ADM doesn't really restrict us the way networking on Kubernetes does. But at the same time, we don't have a bunch of tooling that already exists. So one of the things we need to deal with is the fact that our clients typically expect to talk to the Samba server on port 445. Some daemons in Ceph can be deployed with alternative ports, and if your clients make it easy to specify an alternative port, it allows for things like easy co-location. We don't really have that option. I also mentioned earlier the ingress feature. It's very intriguing. I don't know if it really is going to work well with Samba, and especially Samba with CTDP. On the other hand, I really like to reuse components when they exist. So this is an area that's going to be a lot of research. This is the true, we have to design things from scratch part of this effort. Next is the inevitable, are you going to run NFS and SMB on the same folders question? I think a lot of us have had the experience of this happening. So while we have nothing planned at this time, we kind of expect it's going to be asked down the road. The team is looking into various options, but we don't have any concrete plans at this time. What we do want to do is have both the SMB and NFS manager modules understand that each other exists so that we can exclude one protocol versus another from a particular subvolume, just as a prevent users from shooting themselves in the foot method. Okay, so while I did say this was not a Kubernetes talk, I do have a slide here specific to the Samba operator because I keep mentioning it as an inspiration for the work we've done with Ceph. I'm personally very fond of the work we did on the operator. I love the fact that we have a small but active community of users, but I personally have very little time to spend on it. So this is kind of a mini call to action. If you came to this talk saying, oh, he's going to talk about Rook and Ceph on Kubernetes and Samba operator, and I disappointed you, well, I suggest that you interact with us on our GitHub repo. Maybe you're a Go coder. Maybe you're just starting out in Go. I would love to help coach folks in that space. And, I love to see people help us with some of the feature requests we've got there. And modulo the discussion this morning, one day, if you stick around and stay involved, you can help us maintain the project. So I've reached the end of my slide deck. Hopefully I wasn't too fast or too slow. I wanted to make sure we had about 10 minutes for questions. Once again, my handbook says this is a good time for a call for action. So I will say, please go try out our work in progress PR. There is a container image available that you can just download and use if you are willing to trust my Quay.io repo, which I realize now I didn't link on the slide. So if you do want to try it, you can ping me, or you can wait maybe 2 or 3 weeks. It's a rough estimate, but I hope that's the time frame we have for this PR to get merged. And once the code is on the Ceph main branch, it shouldn't be too hard to give it a whirl. If you don't want to get hands-on with it, but you're still interested, I highly recommend reviewing the doc links I shared earlier. take a look at that and feel free to provide us feedback either in the PR or in the mailing list thread I mentioned earlier. I am available. I've linked a bunch of my various email addresses. I also am on the Ceph's Slack chat. And then finally, there are weekly orchestrator meetings, the Ceph Orchestrator Weekly. It's a pretty self-explanatory name. Those are on Tuesdays. I try to attend as many as I can. So that's also a good venue to come. And it is a user and dev meeting. So I encourage people to join up there. At this point, I've reached the end of the deck, and I hope you have some questions.
So if no one has a question, I have one for you. Just wanted to give everyone else time to maybe raise their questions, but okay. So
yeah, I have a couple audience plants. Couldn't there better come up with a question once you've asked yours?
Okay, so one question: how do you determine and set up the TCP endpoints for the SMB clusters? How is that handled internally in Ceph, such that when you run the Ceph SMB cluster, create blah 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 and so on, then that at the end you can go to your Windows client and just use the DNS hostname to connect to that cluster? How does that work?
So currently, it's very simple. We basically bind our container to port 445. So each node can only run one container instance. We don't, with this basic PR, we don't support co-location at this time. That's actually different from what we get for free in Kubernetes, because you can have multiple SMBDs running all in the same because they have an existing virtualized network. This is why I brought up that ingress thing, because there is some potential there for integrating with that and allowing some level of scale out and clustering. I do think it'll potentially conflict with the IP management of CDDB. So this is really like, if there's anything on my horizon that I'm worried about, it's that. I'm like, I got to get to that work soon. There are some other ideas I've had about assigning virtual IPs to each container, so that if you manually assign virtual IPs, or we do something in Cephadium with a virtual IP pool. I've been discussing this with the Cephadium team lead on and off for the last couple of weeks.
So you can only basically have one SMB endpoint per Ceph
node. Yeah.
Oh, okay. Yeah.
So if you have a 4-node cluster, you can run 4 independent, I'm joined to this domain, I'm joined to that domain, standalone here, standalone there. But once you try to exceed that number, Cephadium will try to deploy it, but it'll just get a port conflict and go, I can't do this.
Yeah. Okay. Yeah. Right. Thanks.
Hi, John. Jeremy here.
Hi.
I'm just wondering if you've been trying testing with the new Ceph VFS module that's been developed on GitLab.
Yes. So the developer, the lead developer there, is also part of my team at work.
Oh, great.
So we frequently talk. I did like a quick one-over review of the code early on when he first posted the merge request. I'm not really a C guy. I can get around in it, but I've done Python, I've done Go. Those are kind of more my style.
Yeah, I think Anoop is going to be talking about that a little later on anyway. And Sachin, but I just So all your stuff will work with that when it goes in, yeah.
Yeah, there's definitely I want to talk about the stuff I knew really well.
Yeah.
Could have tried to expand it, but I didn't want to steal anybody's thunder.
No, it's fair. I'm just kind of excited for that going in. So
yeah.
Thanks.
All right, I'll skim the chat here too.
John, I also have a question. Could you maybe
there you are.
give a hint on what other options are available when you're dealing with credentials? So how is the orchestrator? What kind of different options are there in order to deal with not passing clear text passwords in YAML files?
Yeah, so that is another thing. I probably should have had that on the open issues. Now that I think about it, it's actually in my speaker notes, and I must have skipped over it. Right now, we're storing everything that you feed it. So I would highly recommend, if you try it out with a real AD, you create a dedicated user for joining Ceph. The issue is we have to join things asynchronously, so we don't really have a place to store things other than what Ceph already gives us. I've been told that the Ceph Mon key store is secure, but I'd love to see more. In particular, I've complained that we don't support something like HashiCorp Vault. I'd love to see Ceph support something like that, but also opinions are my own, not my employer and all that. So right now, what we can do is we can store the username and password as a separate resource from the cluster, and we can lifecycle it separately. Something I've been thinking about but haven't implemented is expiring the resource. So giving it a life cycle of like, you can only have this exist in the config for 24 hours, and then it'll automatically delete it. But currently, when you create a cluster, an AD join cluster from the command line, you have to store it forever for now. Does that answer the question? Oh, one other thing is we do store our configurations in two different places in Ceph. Things like the primary config file goes straight into a Rados pool. Things like the users and groups, because they have passwords, and the AD users get stored in this Mon key config store thing, which is, I've been told, more secure. But I haven't personally validated anything.